This video will cover the fundamentals of IP addresses, including IPv4, the subnet mask, and the different types of IP addressing. We will also discuss classful and classless addressing, their limitations, and the concept of subnetting and CIDR. An IP address serves as the unique postal address for your device on any network, including the Internet. It is a unique global address for a network interface, essential for routing data packets like web pages and messages. It is typically configured with subnet masks to manage network traffic. IPv4 is structured using 4 8-bit numbers, or octets, separated by periods. An IP address combines a network ID, which identifies the specific network, and a host ID, which identifies the specific device on that network. The subnet mask defines which part of the address is the network and which is the host. The subnet mask is critical, as an IP address without it is considered ambiguous in an IP network. It separates the network address from the host address, helping programs identify the network and host portions of the IP address. Just like an IP address, a subnet mask is 32 bits long and uses the same notation. For example, a Class C network typically has a subnet mask of 255.255.255.0, indicating that 24 bits are used for the network portion. The two main types of IP addressing are classful and classless addressing, or CIDR. Classful addressing uses fixed-length subnet masks, which can lead to wasted IP addresses. Classless addressing uses variable-length subnet masks, or VLSM, for more efficient and flexible IP allocation. Classful addressing, introduced in 1981, divides IP addresses into 5 fixed classes: A, B, C, D, and E. Class A is for large networks, with a subnet mask of 255.0.0.0, supporting up to 16,777,214 usable hosts per network. Class B IP start from 128.0.0.0 to 191.255.255.255, with a subnet mask of 255.255.0.0, supporting up to 65,534 usable hosts. Class Circa IP start from 192.0.0.0 to 223.255.255.255, with a subnet mask of 255.255.255.255.0, supporting 254 usable hosts. Class D is reserved for multicast, and Class E is for experimental use, neither using standard subnet masks. The advantages of classful addressing include simplicity and low routing overhead, as the mask is inferred from the first octet. The disadvantages of classful addressing include massive IP waste due to fixed block sizes, a lack of flexibility for customized network sizes, and poor scaling capabilities for modern, large networks. Classless addressing, or CIDR, is a modern method that replaces classful systems for efficient IP allocation and routing. It uses slash notation, such as 192.168.1.0/24, where the number indicates the network bits, enabling flexible subnetting and supernetting. Classless addressing offers several advantages, including efficient IP utilization through customized subnet sizes and high scalability for hierarchical network design. It also supports flexibility with VLSM, allowing precise address allocation. Disadvantages of classless addressing include greater complexity in configuration and management compared to classful routing. Also, without proper summarization, routing tables can grow large, although CIDR aggregation mitigates this. In summary, classless addressing is the current, efficient standard. The comparison table shows classless uses variable-length subnet masks, has efficient address usage, supports modern routing protocols, and provides high flexibility. Subnetting in classful addressing involves borrowing bits from the host portion of an IP address to divide it into smaller subnetworks. This improves address space, security, and reduces network congestion. However, a major restriction is that all subnets must use the same mask. The core concept of classful subnetting involves borrowing bits from the host portion and assigning them to the network portion to define a new, smaller network boundary. For instance, subnetting a Class C network by 2 bits changes this 24 mask to A26. The number of subnets created can be calculated as 2 to the power of the number of borrowed bits. The number of hosts per subnet is 2 to the power of the remaining host bits, -2. For example, to create 4 subnets from a Class C network, we borrow 2 bits. The new mask becomes 255.255.255.192 or /26. This results in 4 subnets, each supporting 62 usable hosts. Subnetting in classless addressing uses CIDR to create custom-sized subnets, moving away from fixed class boundaries. The use of / notation enables VLSM, optimizing IP address allocation and improving routing efficiency. Key concepts of classless subnetting include CIDR notation, where the / prefix indicates the total network bits. Flexible masking allows subnets to be precisely tailored to host requirements, such as a 28 for 14 hosts. The number of subnets and hosts is calculated similarly to classful addressing. VLSM permits different size subnets within the same network block. For example, subnetting a 192.168.1.0/24 network to create 4 subnets requires borrowing 2 bits, resulting in a new /26 mask. This creates 4 subnets, .0/26, .64/26, .128/26, and .192/26. Supernetting combines contiguous smaller networks into one larger network. The benefits of using subnet masks include efficient IP address usage, as it drastically reduces address wastage. It also provides scalability by allowing routers to aggregate routes, reducing table sizes, and offers flexibility for network engineers to tailor the subnet size to the exact need. How does a subnet mask work? Step 1 is understanding the subnet mask. It is a 32-bit number that separates the network portion from the host portion of an IP address. It determines which part of the IP address identifies the network and which part identifies the devices within that network. Step 2 involves matching the IP address and subnet mask. The subnet mask is written in decimal notation and aligned with the IP address, like 192.168.1.1 and 255.255.255.0. Step 3 is converting both the IP address and the subnet mask into their binary forms. Step 4 is to perform a bitwise AND operation between the binary IP address and the subnet mask. This operation is critical as it extracts the network portion of the IP address. The result of the AND operation gives us the network address. Step 5 is identifying the network and host portions. The ones in the subnet mask represent the network portion, and the zeros represent the host portion. For example, in 255.255.255.0, the first 24 bits are the network, and the last 8 bits are the host. Step 6 is determining the range of addresses. The subnet mask defines the range of IP addresses within a subnet. For the example 192.168.1.0 network, the usable IP addresses range from 192.168.1.1 to 192.168.1.254. Step 7 is facilitating communication. Devices within the same subnet can communicate directly. If the destination IP is outside the subnet, the data is sent to the default gateway for routing. Subnet masks vary based on network requirements, and there are common types. Default subnet masks are used in Class A, B, and C networks. Class A uses 255.0.0.0, Class B uses 255.255.0.0, and Class C uses 255.255.255.0. Custom subnet masks are created when further segmentation is needed. For example, 255.255.255.192 divides a Class C network into 4 smaller subnets. Variable length subnet masks, or VLSM, allows subnetting with different sizes, which optimizes IP address utilization. If you are provided with CIDR notation such as 192.168.1.0/24, you convert it to a subnet mask using the number of bits. In this case, 24 equals 255.255.255.0. You can also use network tools like ipconfig for Windows or ifconfig for Linux to view the configured subnet mask. As an example, if a company with the IP address 192.168.1.0 wants to create 4 subnets, they would determine the subnet mask as 255.255.255.192, which is equivalent to 26 in CIDR notation. Using this subnet mask, the ranges can be calculated. Subnet 1 runs from 192.168.1.0 to 192.168.1.63, and so on. Each of these subnets accommodates 62 usable hosts. To find the subnet mask from an IP address, you can use the default subnet mask based on the IP address class, convert from CIDR notation, or use network tools like ipconfig or ifconfig. The subnet mask is fundamental to computer networks, enabling efficient IP address utilization, improved performance, and enhanced security. It plays a critical role in segmenting networks, reducing traffic, and isolating sensitive resources. The IP address of a network has the host number set to all zeros, such as 128.143.0.0. The broadcast address has the host number set to all ones, like 128.143.255.255. A broadcast goes to all hosts on the network, but it is often ignored due to security concerns. Now let's look at special IP addresses. All addresses from 127.0.0.1 to 127.255.255.255 are reserved for loopback interfaces, with most systems using 127.0.0.1. The loopback interface is associated with the name localhost. Certain address ranges are reserved for experimental use, and packets with these destination addresses should be dropped. These ranges include 10.0.0.0 to 10.255.255.255, 172.16.0.0 to 172.31.255.255, and 192.168.0.0 to 192.168.255.255. By convention, though not a reserved address, the default gateway often has the host number set to 1. Network Address Translation, or NAT, is how your home router gives private IPs to your devices while getting only one public IP from your internet provider. Everything from your house appears to the internet as coming from that single public IP. Common IPv4 address examples include 192.168.0.1 or 192.168.1.1, which are often your home router or default gateway. 10.0.0.1 and 172.16.0.1 are also common private addresses. 8.8.8.8 is a famous public DNS server, and 142.250.190.78 is an example of a public website address. The network prefix identifies a network, and the host number identifies a specific device. Before 1993, the network prefix was implicitly defined by class-based addressing. After 1993, the network prefix is indicated by a netmask. In summary, a subnet mask is a 32-bit number that divides an IP address into network and host parts for efficient routing. Its purpose is network segmentation, traffic reduction, and enhanced security. You can find the subnet mask from an IP address based on its class, CIDR notation, or with network tools. Common types include default, custom, and VLSM masks. For example, 192.168.1.0/26 uses the subnet mask 255.255.255.192 to create 4 subnets with 62 hosts each. Thank you for watching this video. Please consider subscribing to the channel for more classes.